Lesson: Automated Incident Response using NLP Techniques. Automated incident response using natural language processing techniques is a transformative approach in the field of cybersecurity. It leverages the power of artificial intelligence to automate the detection, analysis, and mitigation of security incidents, significantly reducing the time and effort required by human analysts. The integration of NLP into security operations enables systems to understand and process human language, translating unstructured data into actionable insights. This lesson explores the practical applications, tools, and frameworks that professionals can use to implement these techniques effectively within their organizations. The application of NLP in automated incident response is particularly relevant given the exponential growth of data generated by various network activities. Security logs, alerts, and reports contain vast amounts of textual information that must be processed to detect and respond to threats. NLP techniques can be employed to parse and analyze this data, identifying patterns indicative of potential security incidents. For instance, by using sentiment analysis and keyword extraction, NLP can help in categorizing the severity of alerts and prioritizing them for response, thereby optimizing the incident response process. One of the practical tools used in NLP for security operations is the open-source Natural Language Toolkit. NLTK provides a suite of libraries and programs for symbolic and statistical natural language processing. It is particularly useful for tokenizing text, identifying named entities, and performing part-of-speech tagging. For example, in an incident response scenario, NLTK can be used to extract relevant information from incident reports, such as the type of attack, affected systems, and potential indicators of compromise. This information can then be fed into a security information and event management system to automate the correlation and analysis of incidents. Another significant tool is Spacey, an industrial-strength NLP library designed for practical use in real-world applications. Spacey excels in tasks such as named entity recognition and dependency parsing, which are crucial for understanding the context of incidents described in natural language. By using Spacey, security teams can develop models that automatically extract entities like IP addresses, domain names, and file hashes from unstructured text. This capability allows for the rapid identification of malicious entities and facilitates automated threat intelligence gathering. Frameworks such as Apache OpenNLP and Stanford NLP also provide robust solutions for implementing NLP techniques in security operations. Apache OpenNLP offers tools for processing natural language text, supporting tasks such as tokenization, sentence splitting, and part-of-speech tagging. In the context of incident response, OpenNLP can be used to develop models that classify incident reports based on their content, enabling automated triage and prioritization of security alerts. Similarly, Stanford NLP provides a comprehensive suite of NLP tools, including dependency parsing and coreference resolution, which are essential for understanding complex relationships within incident data. A notable real-world application of NLP in automated incident response is its use in email security. Phishing attacks, which often exploit human vulnerabilities, can be detected and mitigated using NLP techniques. By analyzing the linguistic features of incoming emails, NLP models can identify suspicious patterns indicative of phishing attempts. These models can be integrated into email gateways to automatically quarantine or block malicious emails, thereby reducing the risk of successful phishing attacks. According to a report by the Anti-Phishing Working Group, phishing attacks increased by 65% in 2020, highlighting the need for automated solutions to combat this growing threat. In addition to email security, NLP can enhance incident response by automating the analysis of threat intelligence feeds. Threat intelligence platforms often provide data in the form of unstructured text, which requires manual processing to extract relevant insights. NLP techniques can be employed to automate this process, extracting entities and relationships from threat intelligence reports and integrating them into a centralized threat intelligence database. This automation not only accelerates the analysis process, but also ensures that security teams have access to up-to-date and actionable intelligence for responding to emerging threats. Implementing NLP techniques in automated incident response requires a step-by-step approach to ensure effectiveness and accuracy. The first step involves data collection and preprocessing, where raw textual data from various sources is gathered and cleaned. This step is crucial for removing noise and ensuring that the data is in a suitable format for analysis. Following data preprocessing, feature extraction is performed to identify key linguistic features that can be used for classification and analysis. This step often involves techniques such as tokenization, stemming, and lemmatization to reduce the dimensionality of the data and improve model performance. Once features are extracted, the next step is model training, where machine learning algorithms are used to develop predictive models based on the extracted features. Supervised learning techniques, such as support vector machines and random forests, are commonly used to train models that can classify incidents and predict their severity. These models are then evaluated using metrics such as precision, recall, and F1 score to ensure they meet the desired performance criteria. After model evaluation, the final step involves deployment and integration, where the trained models are integrated into existing security infrastructure. This integration allows for automated analysis and response to security incidents, reducing the need for manual intervention. Continuous monitoring and updating of the models are essential to adapt to evolving threats and ensure the models remain effective over time. A case study highlighting the effectiveness of NLP in automated incident response is the implementation of a chatbot for handling security alerts in a large enterprise environment. The chatbot, powered by NLP, was designed to interact with security analysts and provide automated responses to common security queries. By understanding the context and intent of analyst queries, the chatbot was able to suggest relevant actions, such as blocking suspicious IP addresses or updating firewall rules. This implementation not only reduced the workload on security analysts, but also improved the speed and accuracy of incident response. Statistics further illustrate the impact of NLP on automated incident response. According to a study by Ponemon Institute, organizations that deployed automated incident response solutions reported a 50% reduction in the time taken to resolve security incidents. Furthermore, these organizations experienced a 30% decrease in the average cost of a data breach, highlighting the economic benefits of automation in incident response. In conclusion, automated incident response using NLP techniques offers significant advantages in terms of speed, accuracy, and efficiency. By leveraging tools and frameworks such as NLTK, Spacey, Apache OpenNLP, and Stanford NLP, security professionals can develop automated solutions that enhance their incident response capabilities. The practical applications of NLP in email security, threat intelligence analysis, and incident classification demonstrate its potential to address real-world challenges in cybersecurity. As the threat landscape continues to evolve, the adoption of NLP in security operations will be crucial for organizations seeking to stay ahead of emerging threats and safeguard their critical assets.